Welcome to part 3 of the SPSS tutorial, which focuses on defining steady variables in SPSS. By the end of this video, you will be able to define variables correctly in the SPSS variable view. This is the core learning outcome of this video. In addition, you will be able to explain the purpose of the main variables properties, including name, type, label, values, missing values, and measure, and distinguish between the 4 levels of measurement in research, namely nominal, ordinal, interval, and ratio. In order to demonstrate variable definitions in this part as well as for the subsequent tutorial parts, we consider this conceptual framework. In this conceptual framework, there is one dependent variable, which is academic performance as measured by grade point average or GPA, and there are 7 independent variables which include gender, study hours per day, monthly financial support from family, academic self-efficacy measured by 9 standardized items using 5-point Likert scale, IQ score on the basis of an intelligence quotient test, field of study, which is measured using 4 broad categories, and overall satisfaction of students with academic and administrative services. The overall purpose of this hypothetical study is to examine the extent to which these independent variables influence academic performance by taking sample of 725 students at university. Following the conceptual framework, assume that the questionnaire has been prepared in order to collect primary data from students so that we can address our hypothesized relationships mainly between the independent variables and dependent variable, and it has 5 sections. The first section covers the demographic information of the students. In the second section, it's about academic profile and daily habits. Section 3 contains financial context and service satisfaction. Section 4 about academic self-efficacy scale developed from Hamad et al. It has 9 items measured by 5-point Likert scale, and the last part is about the biography of the students. Preparing a codebook is an essential step before defining variables in variable view. When you say a codebook, it provides a structured plan for defining variables by specifying each variable's name, variable type, variable description or label, the values for categorical variables, and label of measurement. Now let us proceed to defining the variables based on this codebook. So let me open both the data editor window and the codebook side by side, and then we define the variables of our study using the variable view. When the editor window is opened, the variable view is active by default. In this interface, each row represents a single variable, while each column represents its properties in terms of name, type, width, decimals, or label. In the name column, a shorthand name is assigned to each variable. Variable names must begin with a letter, contain no spaces, not end with a full stop, be short but meaningful. To begin with, the first variable of our study in the first cell is gender. Under the type column, data format options such as numeric or string or data are selected. For this, click the blue 3-dot box and select the appropriate option. By default, SPSS creates numeric variables. For open-ended questions, select string. If you have a question related to calendar dates, then select date. In the case of gender, as per our codebook, we have 2 categories, male and female. male is coded as 1 and female is coded as 2. So we can assume it as numeric. Though it is categorical variable, we can instruct SPSS to assume male as 1 and female as 2. So it is considered as numeric. Under width column, we specify the maximum number of characters or digits that a variable can display. For numerical variables, maintain the default width. For questions requiring text responses, for string data format, an appropriate width should be specified in order to accommodate the expected length of the response. Decimals determines how many decimal places are displayed. So in this context, we maintain the default width. Under decimal, since it is categorical, coded as 1 and 2, decimals are not required. Then it's better to set 0 decimal. The label column allows the user to provide a complete description of the variable. It is this description that appears in the analysis output. Therefore, it is important to provide a complete and meaningful full description for the variable. In this particular case, the full description is gender of the student. The values column allows the user to assign numerical codes to categorical variables. We click the blue 3-dot box and then we provide value and label as per the specification given in the codebook. 1 represents male, then we click add, and the second value is number 2, it represents female, and click add. Once you have finished entering all categories and giving the value for all categories, click OK. The missing column is used to define specific codes for missing or unavailable data. A code outside the range of valid responses is assigned, for example, 999. So, just like value and type of variable, we click the 3-dot box and then by selecting discrete missing values, we type 999 and click OK. By doing so, SPSS treats specified codes as missing values and automatically excludes them from analysis. Columns and align, these settings affect only the display of the data in the output viewer window. Columns controls how wide each variable appears in data view, while align controls whether values appear left, center, or right. Thus keep the default settings for both columns and align. Under the measure option, select the appropriate level of measurement for each variable. Let me briefly explain the 4 commonly used levels of measurement in research. The first level of measurement is nominal scale. The nominal scale is the simplest level of measurement. It groups observation into named categories that are mutually exclusive and exhaustive. Examples include gender in terms of male and female, marital status by categories such as single, married, divorced, and widowed. And another example is bank ownership, in which we could categorize in terms of public and private. The numbers associated with variables of this scale are only tags for categorization or division. For example, if we assign 1 for male and 2 for female, they don't have any numerical value. They serve only for categorization purpose. The second level of measurement is ordinal scale. The ordinal scale, like nominal scale, also categorizes variable into labeled groups, and these categories have an order or hierarchy to them. These categories can be ranked from lowest to highest or vice versa, but intervals between ranks are not assumed to be equal. Examples include educational level in terms of diploma, bachelor's, master's. Socioeconomic status categorized as low, middle, or high, and satisfaction level in terms of very dissatisfied to very satisfied. The third level of measurement is interval. The interval scale has all the properties of the ordinal scale with the additional feature that the distance between consecutive points are equal and meaningful. It ensures equal distance between intervals on the scale, but the interval scale lacks a true 0 point. 0 does not mean the absence of the measured attributes. For instance, temperature measured in degree Fahrenheit uses a relative 0. 0 degrees Fahrenheit does not represent an absence of temperature. Similarly, IQ score of 0 does not denote the complete absence of intelligence. The fourth level of measurement, which is the highest level of measurement, is ratio. Such kind of variables and data have equal intervals and a true 0 point, meaning that 0 represents the complete absence of the quantity being measured. As a result, all arithmetic operations such as addition, subtraction, multiplication, division are valid. Examples include income, number of children, work experience. SPSS classifies both interval and ratio as a scale representing quantitative data. Having these levels of measurement in mind, it is very easy to select the level of measurement or simply measure in SPSS for each of the variables of our study. In the case of gender, out of scale ordinal nominal, it is nominal scale. The second variable is date of birth. Then we take the shorthand under the name column. Under the type column, date of birth is about the date. Then from the blue 3-dot box, we have to tick date. And out of many formats for the date, we select the preferred format. In this particular case, let us take the second format, which uses date in the beginning, month in the middle, and year as the last. We select the format and then click OK. Under label, we type meaningful and complete description for the variable, in this case, date of birth. Under values, since it is the date format, no need to provide values. For other columns, we maintain the default. Under measure, out of the three options, date of birth could be categorized under nominal. The other variable is field of study. It represents a student measure field of study where we have used four broad categories. This is categorical data and numeric because we assign numerical codes for the categorical variable. Decimals 0 and the full description is student measure field of study classification. The values we need to specify the four categories. The course should be given here as per our code of book. 1 represents natural sciences. Click add. 2 represents business and economics. 3 represents social sciences and humanities. Click add. And technology and engineering is represented by code number 4. Click add and OK. For missing value, we need to do just like for gender. For column and align options, we maintain the default. Measure, it is categorical variable, so it is nominal. We select nominal. The study hours per day is average daily hours spent is ratio. So SPSS considers both interval and ratio as a scale. Then the variable name is study hours per day. Then we type study hours per day. As you can observe here, if you want to combine many words or terms as one variable, we can use underscore, just like this, study underscore hours underscore per underscore day. Under type, we just retain the default. The same again under with, we retain the default. Under decimal, since study hours per day could take decimals, So we retain the default, which is 2 decimal places. The label, we need to give meaningful and complete description, which is average daily hours spent studying. Under value, since this is ratio type of variable, numerical values are not required in this case. Numerical values are required only for ordinal and nominal levels of measurement. Then the measure for study hours per day, the measure is ratio type of data and SPSS considers as a scale. Then we select the scale. Next, GPA, which is the shorthand name of the variable. It's numeric. We maintain the width as it is, and decimals again. We retain the default. The label is academic performance. Values are not required here because it is continuous, and the measure, it is scale. Then IQ score, the shorthand variable name, IQ score is numeric, and we maintain the width, we maintain the default. For decimal, we don't need, it is in the whole number, so we set the decimal as 0, and the label is intelligence quotient test score. IQ is typically interval levels of measurement. SPSS considers both interval and ratio as scale. Then we select the scale. The next variable is overall satisfaction, which represents overall satisfaction with academic and admin services, measured by 3 points from dissatisfied to satisfied. So this is the ordinal level of measurement. Under name, we give overall satisfaction, and we maintain the type and width, the default. Under decimal, since it is by 3 points from 1 to 3, so decimal places are not required, so we set as 0, and its full description is overall satisfaction with academic and admin services. Here the values are required. It is categorical type of data, and still hierarchy has meaning. It is ordered, and again there are categories. It's ordinal type of data. As a result, we need to specify the numerical codes for the categories so that the analysis would be very easy. And number 1 represents dissatisfied, add. Number 2 represents neutral. Number 3 denotes satisfied. Then click OK. We can specify the missing value as 999 for all variables. For column and line, we can maintain the default. Under measure, overall satisfaction as measured by the 3 points, which is ordinal type of data. It's ordinal scale. We select ordinal. The other variable is monthly financial support, which is continuous type of data. It's ratio type of data. Its full description is monthly family financial support in USD. The decimals are required in this variable context, so we maintain the default, which is 2 decimal places. Values are not required because it is continuous or ratio type of data, and the level of measure is ratio, which is considered as a scale in SPSS. The other variable is academic self-efficacy items. There are about 9 items in academic self-efficacy. The first item is SE_1, the first item. So numeric width, then we maintain numeric and width as default. The decimal place, since it is categorical and we use 5 points from 1 to 5, decimal places are not required, so we set 0 decimal place. Specifically, the first item is about time management and scheduling. Under label, under values, we need to specify the numerical codes for 5 points Likert scale, ranging from strongly disagree up to strongly agree. So here we need to specify the 5 categories. Using the blue 3 dot box, we give numerical codes for the 5 categories. 1 represents strongly disagree, 2 represents disagree, 3 implies neutral, agree is represented by code number 4, and 5 shows strongly agree. Click add, and then once you have completed providing values and label for all categories, we click OK. This is basically ordinal scale. Then following the same procedures, we define the properties of the remaining 8 items for academic self-efficacy. Our last variable is biography. Its shorthand is bio. It is open-ended type questions. So it's not numeric. Rather, we expect text responses. Then we need to select appropriate data format option from the type column. And since it is open-ended type question, it is string. So we have to select string here, and adequate space should be provided. In our questionnaire, we request the students to provide their biography in not more than 1000 characters. And therefore, the width here should be set 1000 characters so that we can get complete response. Decimal places are not required, values are not required. Once variable definition is complete, remember to save the file. To save the file, we could either use the menu or the toolbar, the shortcut. From menu, we just go File, Menu, Save as Submenu, and we provide a descriptive file name and save. The next step is to enter the data into SPSS using the Data View tab. Thank you for watching. Please subscribe to my channel so you don't miss any upcoming tutorials.